Imagine this. You're cruising peacefully at, say, 30,000 feet. The sky's crystal clear, everything's smooth. And then, without warning, the world outside your window starts to turn frosty.
Yeah.
Now, this isn't just about a scenic view changing. Ice and frost on an aircraft, well, they're far more than just an aesthetic concern. They're a fundamental, sometimes pretty insidious threat to the very essence of flight.
Absolutely.
We're talking about significant, sometimes even catastrophic changes to how an aircraft performs. Everything from its ability to generate lift, which is pretty vital, to its very capacity to stay airborne.
It's true. It's kind of an unseen enemy that demands constant vigilance, really sophisticated engineering, and crucially, a pilot's acute be higher when you think about what ice can actually do.
And that's exactly why today we're taking a deep dive into aircraft ice and rain protection systems. Our mission here is to unpack the critical knowledge you'll need, especially, and this is important, if you're preparing for those challenging ATPL theory exams.
Right.
We're going to really emphasize the key concepts, maybe reveal some surprising details about how engineers tackled this problem, and provide a comprehensive overview. The goal is to help you master this vital subject, make sure you're not just informed, but genuinely ready to ace those questions.
Yeah, and we're pulling our insights today from specialized excerpts on ice and rain protection. We're covering, well, pretty much everything from the fundamental aerodynamics of icing right through to the really intricate systems designed to combat it.
Okay.
This deep dive is really designed to distill some complex information into actionable knowledge, giving you that essential sort of shortcut to being well-informed and fully prepared for those exams.
Perfect. So let's start by unpacking this silent threat. Why does ice and frost even matter? What are the immediate and maybe long-term consequences for an aircraft, whether it's soaring through the sky or even just sitting there on the tarmac?
Well, what's truly fascinating, or maybe terrifying, is the core impact. Without exception, any formation of ice or frost on an aircraft's surfaces will detrimentally affect its aerodynamic performance.
Any at all.
Any. It fundamentally alters the precise aerodynamic contours the aircraft was designed with. And, perhaps even more critically, it significantly affects the nature of the boundary layer, that incredibly thin but absolutely crucial layer of air immediately adjacent to the surface of the wing or fuselage.
And when we talk about critical surfaces, the wing immediately comes to mind. Is that really the most important one? Or are there other areas where ice formation might have an equally or maybe surprisingly catastrophic impact?
You're right to highlight the wing as, well, paramount. Ice or frost formation there can create really profound changes in its aerodynamic characteristics. Let's maybe look at the specific consequences.
Okay.
Firstly, you get considerable increase in drag. Those large changes in local contours, combined with the extreme surface roughness you get with some forms of ice, they dramatically increase skin friction. And this translates directly into a massive amount of undesirable drag.
More drag means you need more power just to maintain speed, which already sounds like a problem.
It absolutely does. Secondly, and this is perhaps even more critical for flight safety, there's a significant reduction in the maximum lift coefficient, or CLmax.
CLmax.
Yeah, that's the maximum lift the wing can possibly generate.
Yeah.
A lower CLmax means the wing simply can't generate as much lift as it's supposed to.
Right.
So as a direct result of both that increased drag and the reduced lift, you'll need more power to fly and your stall speed increases. This is a really crucial point for anyone thinking about flight dynamics, and definitely one for the ATPL exam.
Yeah, that stall speed increase is key.
Definitely. And of course, let's not forget, the physical accumulation of ice itself adds undesirable weight, which just further compounds all these issues.
So it's this brutal combination: more drag, less lift, and an added weight. You mentioned different types of ice formation earlier. Can you elaborate a bit on those?
Sure. The sources outline three main types. You've got hoarfrost, then rime ice, and finally clear or glaze ice.
Glaze ice sounds bad.
It often is considered the most dangerous,
Yeah.
Mostly because of its tenacity, how well it...
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best.